Hello Year 5 and welcome to your reading lesson for today. So we're going to be carrying on with our concept of adding fractions, but rather than adding two fractions like we did yesterday, today we're going to look at adding three or more fractions. So the same principle applies. We're still going to be looking for our common denominator so that we can change or convert our fractions, but this time I'm just going to add some additional fractions to it. But before I do that, let's warm your brains up a little bit. Okay, so there is a fraction question in here and there's a link to some of the previous topics that we've looked at. So as usual, set yourself a 5-minute timer, pause the video and have a go at these questions. Okay, the first one, 1/3 is the same as something over 15. So you need to think, well, how do I get from 3 to 15? Well, we multiply that by. Good. So we know that we're multiplying that by 5, therefore 1 times 5 is 5. Okay, so we're missing that 5 over there. What is 568 divided by 4? It's 142. We know it's going to be an even number because 4 goes into 8 exactly twice. We know there's no remainders. What is the area of this rectangle? So if it's the area, we have to multiply them together to give us that middle number. When it's area, it's got to be to area, centimetres, millimetres, metres, squared. Okay, so the answer is 126 millimetres squared. Now, how many lines of symmetry does a rectangle have? So when we're looking at symmetry, think, well, how many times can I fold it exactly in half and each side be equal? And we did this one on the board just before we broke up at Christmas, and there's only 2. Okay, we know we can't have a diagonal over there, okay, because we don't have 4 equal lengths, okay? So well done if you got those correct. If you've made any mistakes, please go back and correct them, okay, so that you know where it is that you went wrong. If you've had a go at doing the time question on here, I am looking at the time here. It is 13 minutes past 10, so it's going to be 10:13. If it's going to be at night time, so we're looking at 24-hour clock and it's the evening, it's going to be 22:13. Sorry, 15, 16, 17, 18 is what I said. 18, 10:18 or 22:18. My apologies, I was reading it backwards. Silly me. So well done if you got the time correct for that one as well. Right, so let's warm your brains up now a bit more for our fractions work that we're going to be doing today, okay? First one here is easy, just adding these up. You might have to find some common denominators here to help you. Same for these ones here, okay? You need to think about how you're going to work backwards and forwards, okay? So pause the video, give yourself a 5-minute timer, okay? And have a go at those questions. Off you go. Okay, Keaton, if you are currently sat at school, or any of you that are sat at school that see me trying to stifle my yawn, please just ignore it. I'm not tired. I'm recording this in the middle of the day. So I apologise if you can see me trying to hold in my yawn. I don't know what's wrong with me, but it seems to happen every time I record. Okay, so let's go through the answers now that that thought process is out of my head. So if we add all these 3 numbers together, okay, we've got 54, we've got 77 and 46. Now, it makes no difference which way around we do them, but if you notice your number bonds to 100, 54 add 46 there gives us 100, okay? So we've got 177, okay? So it's interesting if any of you actually picked up on that. Here we need to have a look at our common denominators. Well, all of these numbers here are a multiple of, are a factor of 12. So all 3 of these numbers can go into 12, so we can change our denominators so they're equal to 12. Okay, so we've got 8/12, add 1/12, add 2/12. So if we add them all together here at the bottom, in total, we have got ourselves 11/12, so 11/12. Now here we need to think, well, how do we get from 7 to 21? We know we multiply that by 3, so 3 times 3 is going to be 9. And then we need to think to ourselves, well, how do we get from 9 to 15? Okay, now it's got to be equal to, okay? So if you think about it, we've got 3/7, you've got 9/21, we've then got 15/35, okay? So you've got to be able to work out the difference between the numbers, okay? Right, so let's have a look at our learning for today, okay? So the first question we're going to look at here is 3/16, add 1/4, add 1/2 equals. Now you can see that looking at the rules that we looked at the beginning of this unit, we either need to have all the numerators the same, we need to have all the denominators the same. Now that only applies when we're looking at the adding and the subtraction. Okay, subtraction, not take away. Okay, as Miss Ashford keeps telling me, Miss Humphrey, it's not take away because it's not KFC they're eating. So I do apologise, slip of the tongue, subtract. Okay, I know all of the year 5s currently sat at school are shouting at me at the moment. So we need to make sure that our denominators are all the same. So we need to think, well, what's the common multiple, okay, or the common denominator in all of them? Well, we know that 4 goes into 6, and we know that 2 goes into 16, so we can match our denominators to be 16. Okay, so this one is going to be 4 over 16 because 4 into 16 goes 4 times, so you have to multiply the numerator. 2 goes into 16 8 times, so then we've got to multiply our numerator by 8 as well. That's going to give us 8 out of 16. So here we've got our 3 sixteenths. We're then going to add our 4 sixteenths, then we're going to add our 8 sixteenths. Now we know there's 16 altogether, and we've got one less. So we know that's going to be 15 out of 16. Okay, with me so far? Okay. Now that I've shown you how to do that and you've had a look at the common multiples here that we've got for our common denominators, I want you to have a go at doing this one. Okay, so which one of these denominators could we make them all the same as, and how would we add them onto the bottom, and what would my answer be? Pause the video and have a go. Okay, so we know that they'd all go into 24. Okay, so 2 goes into 24 12 times, 6 goes into 24 4 times. Okay, so if we multiply 2 by 12, 1 by 12, it gives us 12. 1 multiplied by 4 is going to give us 4. And obviously we've got 3 out of 24. So we've already got our 3. So then what we're going to do is we're going to go on and we're going to add our 12, and then we're going to add on our additional 4. So if we count them all together, we'd have 19 out of 24. Okay. So well done if you managed to get that right and you matched the same denominator. So let's consider this now in a problem solving situation, because it's all well and good me giving you the 3 fractions, but you need to be able to identify those 3 fractions and that sum on your own. Okay, so let's put it into the context of a problem. So Dexter eats 3/14 of a cake and Eva eats 1/7 of that same cake. Mo also then eats half of that cake. So between them, they've all eaten parts of the same cake. We need to work out how much cake is gone, how much has been eaten altogether. So we need to identify what our fractions are and what our operation is going to be. So we know we've got 3/14 and 1/7. What's my missing fraction? Good. It says 1/2, but it doesn't show it to us as a fraction. Now, if we've got to work out what they've eaten altogether and then work out the difference, what do I need to do to all 3 of those fractions? Good. I'm going to add them together. Okay. So we've got 3/14, 1/7, and 1/2. Okay, so now what we need to think is, how are we now going to progress and move on to work out how much it is that they've eaten? What do I need to do to my denominators? Good, I need to change the denominators. What am I going to change all the denominators to? Good, I'm going to change it to 14 because 7 goes into 14 twice and 2 goes into 14 7 times. Okay, so if we're multiplying 7 by 2, we've got to multiply 1 by 2, so it's going to give us 2. And 2 into 14 goes 7 times, so 1 times 7 is going to give us 7. So we've got to add 3, 2, and 7 together. We know that the 7 and the 3 equal 10, so it's just 10 add 2. It's going to give us 12 out of 14. Can that be my final answer? Or can I simplify that? Okay, I can simplify that. Now I'm going to tell you a rule when it comes to simplifying, because some of you think, well, I don't know how to simplify. And if you're not very strong on your times tables, that actually makes it quite difficult. So the best thing to always do, like we do when we write our factors, we always start with 1 and that number. Then we work our way up to 2. If 2 doesn't go in, we then work out 3 and what the matching number is. Same rule applies when you're simplifying. Start with the smallest number that you can divide by. So we're going to start, and it's always going to be divisible by 2, because dividing by 1 is going to give us the same answer. So we need to think to ourselves, well, can we divide both of those numbers? So that's important. They've both got to be divisible by the same number. Are they both divisible by 2? Now, in this instance, they are. If they weren't, and we had maybe 15 and 30, we could say, oh, we could divide it by 5, or we could divide it by 3, and then you'd work out how many divide by. But luckily for us, these both divide by 2. So let's work out how many 2's are in each one. So how many 2's are in 12? 6. And how many 2's are in 14? 7. So it'd be 6 over 7. Easy peasy. Now you can always simplify things to a smaller number, okay? Depending on what it was. So if that was going to be 12 over 16, I could simplify it by 4. But then even if I simplified it by 4, that would still be 3 over 4, okay? So it would then be 3/4, okay? So that would be the smallest. So you're always going to try and simplify by dividing it by 2 and then see how you get on, okay? Now if I partitioned this with my original fractions, okay, altogether then I'm starting off with 6/7. That's how much they've eaten. And the fractions that add up to those 6/7 is going to be the 3/14, the 1/7, and the 1/2. Okay, so although they've all got the different denominators, that's effectively what you managed to work out. You've got the total amount they've eaten, and it's those parts of the cake that they've eaten that have totaled that amount. Okay, so what I want to do now is pause the video. I'd like to have a go at doing questions 1 to 4 on your worksheet, please. Okay, so let's now make this a little bit more difficult. Okay, so we did one of these examples potentially at the beginning of the week, I think it was, possibly Monday or Tuesday. Might have even been something we looked at before half term. But this is where we've got our missing number, so we need to be working things out backwards and forwards. Okay, so can we see a common denominator? Good, we can see 30, okay? 6 goes into 30, 5 goes into 30. So I can change all three of these denominators, okay? So 6 goes into 30 5 times, so 1 times 5 is 5. 5 goes into 30 6 times, okay? But I can't work out what that number is yet, okay? But I know that I've had to multiply it by 6, and if I'm doing it backwards, I have to divide it by 6. That's an important thing to remember, okay? And then again, we know that 5 goes into it here. 5 goes into it 6 times, therefore 6 times 3 is 18. So what we need to do first is, rather than trying to work out that number, let's work out what we already have, because that's going to tell us the missing value that's going to get us to 18. So what we need to do first is add 7 and 5 together. Okay, what is 7 add 5? Good, 7 add 5 is 12. Now to work out this missing number, we need to think of that we've got the 12 and we've got the 18. So how can I work out the difference to tell me that missing number? What would my sum be? Good, I'll do 18 take away 12. 18 take away 12, okay, if I look at this in my fractions at the moment, it's 6, isn't it? Because we've got 7 add 5, to get to 18 we need 6. So that's going to be my missing number there, 6. So now I'm going to fill in the box above, and I'm going to put 6 in that top box. Is that correct? Can that number be 6 and that number be 6? No, it can't. Why not? Okay, so when we multiplied our denominator, we had to multiply the numerator. Now we multiplied 5 by 6, so we had to multiply something else by 6, okay, to give us this answer. So if we're now going to do the inverse, we know that 30 divided by 6 was 5, so now we need to do 6 divided by 6. What's 6 divided by 6? Good, 6 divided by 6 is 1. Now we can check this, okay, 1 times 6 is 6, 5 times 6 is 30. That gives us 6 over 30. So sometimes you need to be careful about them working out the numbers backwards, okay? So now that you know that, I'd like to have a go at this one. Now, this one is a trick one. I have been mean with this one, because most of the time we round our denominators up to the biggest number that there is. However, if you have denominators, okay, that are equal in as even numbers, there is the potential that we could simplify them, okay? Now, this one is the one I need you to be thinking about, okay? Compare these two denominators, think about what we could do to simplify that fraction, what we could change all these denominators to, and that will give you a clue. Okay, so pause the video and see if you can work out what it might be. Okay, well, we know that double 14, 2 lots of 14 is 28. So we know if we halved this fraction, that's going to give us the denominator 14, okay? So let's halve it, okay? 14 goes into 28 twice, okay? So we divide it by 7. Okay, so we've got 7 here as the denominator. Okay, we can change this one to 7 as well, okay, because 7 goes 7, 14, 21, 28. Now I know that I can get 28 into 7 4 times, so I then have to divide this by 4, so it gives me 2. So then I've got my 2 sevenths here, okay, and I've got my 5 sevenths and my 1 sevenths, okay. Now if I know that this is 5, I've got my 1, and I've got my 2. So adding those together, that gives me 3. Now I need to get to 5. So how do I get from 3 to 5? Good. I'm going to add 2. Okay. However, thinking back to the rule here, we had to divide these ones here. Okay. Now if we've divided this time round, how are we going to do the inverse to work out the original number? Good, so this time we multiply it. Because we made our denominators smaller, so they all matched, we had to divide it. So in order to go back to a bigger number, we've got to multiply it, because when we multiply a number, it gets bigger. So we need to think, well, how do we get from 14 to 7? Okay, well, we divided it by 2. So let's now multiply by 2. So 2 multiplied by 2 is going to give us 4. So 4 becomes that missing number. Okay, so that one's a trick one, because we actually made the denominators all smaller, but that's only possible if we know that all those numbers are divisible by that smaller number, okay? Had that number been too small, we wouldn't have been able to do that, okay? So well done if you spotted that one. So now that I've shown you that one, let's see if I've now confused you a little bit too much. I'd like to have a go at doing questions 5 and 6 on your worksheets for me. I'm not going to send home any additional worksheets at the moment, because I'm very well aware this is a very big unit, and obviously we're coming back to school in 2 weeks' time, okay? So I just want us to primarily focus on these tasks, because there is the potential when we come back, we might be spending a few weeks doing recaps, okay? So for the time being, I just want you to have a go at doing these questions, okay? So have a go at these ones and let me know how you get on, okay? Good luck, year 5.